Ever wonder why holding a heavy box just makes your arms burn, but climbing a few flights of stairs leaves you, completely wiped out? You'd think the answer is all about biology, right? Well, it's not. It's actually physics, and we're going to break down the very real, very physical reason you get tired.
So this question, it seems super simple on the surface, doesn't it? But it actually gets to the heart of this huge mix-up we all have about energy and effort. And the answer has almost nothing to do with your personal strength and everything to do with a core concept in physics called work.
And right there, that's the first major clue. See, the word work in everyday life, trying hard, feeling the strain, means something completely different than it does to a physicist. In physics, work isn't a feeling. It's a specific, measurable transaction. And once you get that difference, man, it changes how you see everything.
Okay, to really get our heads around this, we need to reframe how we think about energy. So stop thinking of it as a feeling, like, I have energy today. Instead, let's imagine it's like a universal currency, like there's a cosmic bank account for the entire universe. In this analogy, it's perfect because it helps us track where the energy comes from, where it goes, and why some things just seem to drain your account way faster than others.
All right, before we dive into the bank account, let's just hit reset on the definition of energy itself. Because in physics, it's not a feeling. It's super simple. Energy is the ability to cause change. Full stop. If something can make something else move, or heat up, or get lifted, it has energy. That's literally it. It's just a measure of potential action.
So the number one rule of this universal bank account, it's a closed system. The total amount of this currency in the universe is fixed. It's locked. You can't make more, you can't get rid of it. All that ever happens is it gets transferred and transformed, from the chemical energy in your lunch, into the energy of you walking down the street, and then into heat.
Okay, so let's stick with our bank account analogy, because this is where it starts to click. Just like your bank, the universe pretty much has two main types of accounts for this energy currency. Think of it as a savings account for stored energy and a checking account for energy that's being used right now. Let's break those two down. First, you've got your savings account. In physics, we call this potential energy. This is all the energy that's just stored. It's waiting to be used, and its value is all about its position or its state, like how high up something is. Then you have the checking account. This is kinetic energy. This is energy in motion. It's the cash being spent right this second. And this stored savings energy, man, it's everywhere. It's totally hidden in plain sight. That car parked at the top of a hill, that's a ton of stored energy just from its height. A stretched rubber band, same thing. The food in your stomach, the charge in your phone's battery, it's all just potential, waiting for the right moment to be spent.
Okay, to really get a feel for the most common type of stored energy, the kind that comes from height, there's this fantastic analogy. I want you to imagine that gravity isn't some weird, mysterious force. Instead, picture it as a giant, invisible rubber band that connects every single thing to the center of the Earth.
This really makes the whole cycle so clear. When you lift something up, you are literally stretching that giant rubber band, fighting its pull. And all that effort you put in, it gets stored as tension in the band. So when something is way up high, that rubber band is stretched tight, just loaded with potential energy. And then what happens when you let go? The band snaps back, and all that stored height energy instantly turns into the energy of motion as it falls.
All right, so we've got our two accounts, right? Savings and checking. The big question is, how do you move the money between them? Well, in physics, that transaction has a name. It's called work. Work is the actual process of transferring energy from one account to another or from one form to another.
And this brings us right back to that super important difference. A force is just a push or a pull. You can think of it as just trying to make a transaction. But work is the successful transaction. It only counts as work if your force actually makes something move over a distance.
Okay, let's make this crystal clear. Picture this. You are pushing against a solid brick wall with everything you've got. You're sweating, your muscles are on fire, you feel totally exhausted, you've applied a huge amount of force. But did the wall move? Nope, not an inch. So in the language of physics, you have done zero work on the wall. No energy was transferred to it. Now, your own biological energy account is draining like crazy, but the wall's energy account, it hasn't changed one bit.
Now, let's compare that to just lifting a book off a table. It feels like nothing, right? But think about it. You applied a force, up, and the book moved a distance, up. force plus movement equals work. Boom! You just completed a successful transaction. You took some of that chemical energy from your body and transferred it into potential energy, now stored in that book because it's higher up.
So, work is an energy transaction. Simple enough. But just like with the real bank, there's always a catch, isn't there? Every single energy transaction in the entire universe comes with a service fee, an unavoidable tax. And that tax is always paid as heat.
Get this. When your body does work, like climbing those stairs, it is shockingly inefficient. I mean, it's terrible. When you spend the chemical energy from your food, only about a quarter of it, 25%, actually turns into useful motion. So where does the other 75% go? Poof! It's instantly lost as waste heat. That's why you get warm when you exercise. It's why you sweat. You are literally just venting all that wasted energy, all that inefficiency.
And look, this isn't just some flaw in our biology. This is a fundamental rule of the universe. It applies to everything. Think about an old-school light bulb. Yeah, it makes light, but mostly it just gets hot. A car engine moves you down the road, but it gets so incredibly hot it needs a whole cooling system just to survive. Your phone getting warm in your hand? Same exact reason. Every single energy transaction pays the heat tax.
Okay, let's recap. We have our energy bank account with savings and checking. We know that work is the transaction that moves the money, and we know every transaction gets hit with a heat tax. So we've basically just built ourselves a pair of physics goggles. Now let's put them on and take another look at that original question.
All right, goggles on. First, holding that 50-pound weight. Is it moving? Nope, it's just staying still. So are you moving it over a distance? No, which means the amount of physics work you are doing on that weight is zero. A big fat zero. Yeah, your muscles are screaming and burning energy just to hold that contraction, but none of that energy is actually being transferred to the weight itself. Now, what about climbing stairs? Well, you're applying a force to lift your entire body weight, and you are definitely moving at a distance, upwards. You are doing a huge amount of work.
And there it is. That's the answer. Climbing stairs wipes you out because every single step you take is a massive energy transaction. With each step, you are actively transferring chemical energy from your body's checking account into potential energy, your new height, in your savings account. And on every single one of those transactions, you are paying that massive 75% heat tax. So the tiredness you feel, it's coming from two places: the actual work of lifting yourself and the enormous amount of waste heat your body has to generate and then deal with just to make it happen.
You know, there's one last little piece to this puzzle, and it's a concept called power. Power is just how fast you do work. It's the rate of the energy transfer. Think about it, walking up a flight of stairs and sprinting up that same flight. It's the exact same amount of work. You move the same weight, the same distance. But sprinting requires way more power. It means you're draining your energy checking account at a much faster rate. And that intense, rapid withdrawal, that's what leaves you breathless at the top.
And really, that's the whole thing. Those are your new physics goggles. From now on, you can just look at the world around you and see these energy transactions happening everywhere. You can look for the stored energy in the savings account, spot the moving energy in the checking account, and always feel for that heat tax being paid.
So, now it's your turn. Try on these goggles. You know, when a car slams on its brakes, where does all that energy of motion go? Or why does your phone get hot when it's charging? What other little energy transfers do you see happening all around you that suddenly make more sense? I'm genuinely curious. Drop a comment and tell me what you've noticed. And hey, if you like breaking down stuff like this, let me know and we'll do more.